Saxon Algebra 1/2, Lesson 89. Greetings, students. We have, including this lesson, 8 more lessons before spring break. I'm excited. Are you? I know you are, so you don't even have to answer me. Lesson 89 introduces you to one of John's tricks that he uses quite often in the upper levels of his curriculum. He puts multiple topics into an individual lesson, and he gives like an A or a B or even a C part or a D part. And at the beginning of Algebra 2, I think there's one that goes up to G or H. It's a nasty trick, you guys, because a lesson of math is supposed to be one thing, but sometimes John loads us up. So that can be exhausting, but this time it will not be a big deal at all. The 2 topics that we're going to cover today are related to each other, but I could have just presented it as one, but I wanted you to be introduced to this idea that John sometimes doubles down and we have to be tough. All right? He's introducing us to something called the Trichotomy Axiom today. Doesn't that sound like something really, 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 really hard? Spoilers, it's not. Write this down. I'll give you a second to write it down and then I'll get to the punchline. And just to recap, I'll read this. If we have 2 numbers, A and B, there are 3 possibilities, okay? The first possibility is that A is greater than B. All right, I hope you're shaking your head up and down going, yeah. The second one is that A is equal to B. Yeah. And the third one is that A is less than B. This is not exactly challenging, is it? 2 numbers, either the first one is greater than, equal to, or less than the second one. That's all there is to the trichotomy axiom. That's all there is. And that gives us rise to 4 inequalities. And I'll continue to use our A and B. A can be greater than B. A can be greater than or equal to B. A can be less than B. And A can be less than and equal to B. We've done this all along, haven't we? Right? We've been using this, I believe, for quite some time. So this is all familiar. And of course, A can be equal to 2, but I'm limiting this list to just the inequalities. All right, now what we're going to do is we're going to introduce a new kind of symbol, and here's where the B comes in. And these are called symbols of negation. And again, that sounds really hard, doesn't it? But if we count these as 1, 2, 3, and 4, we can write this a different way. We can say A is not less than or equal to B. If it's not less than and it's not equal to, then the only thing that it can be is greater than. Do you see how these 2 go together? Let's try the second one. If we want to say that A is less than B, then we can also say A is not greater than or equal to B. If it's not greater than and it's not equal to, then it must be less than. You get it? It's like, you know those signs, sort of the universal traffic sign that shows a picture of something and then slashes it out? That's what these symbols of negation are like. Let's do the third one. If we want to say that A is greater than or equal to, it's either one of those, then we say A is not less than B. That goes with this, right? If it's greater than or equal to, then we just say, okay, it's not less than. And then we can look at the chart and figure out, okay, well, if it's not less than, then it's either greater than or equal to. And that's exactly what we said. And then for this fourth one, if we want to say that it's less than or equal to, then we say A is not greater than B. And that goes with this one. All right, so these symbols of negation just say not what's underneath this slash mark, right? It's not what's underneath there. And then we can consider our three possibilities to say, okay, well, if we know what it's not, then we can rewrite it as what it actually is. Make sense? Oh, good. I'm so glad that you think so. Let's look at some examples, and you'll see how these problems are pretty straightforward. Graph on a number line. X is not less than 2. Okay. Now we know there's 3 options, and sometimes it helps to start by saying how many did we cross out? We crossed out 1, right? We crossed out less than. So that means there's 2 that will show up in the positive version, right? Because there's 3 in total. So if we crossed out 1, that means there's 2 positive. If we cross out 2, that means there's 1 positive. And everything else stays the same, and then we graph it, and look, I'm going to just be so straightforward. Here's 2. Here's the circle. It includes 0.2, so I color it in. And those are all the values where x would be greater than 2. Those are all the values for x that will work. All right, example 89.2. Graph on a number line. Just like I said last time, it helps to look and see how many you've ruled out and know that the total number of options is 3. So if we've ruled out 2, that means there's only 1 left. It's the one that's not showing. X is less than -1. So I can draw my picture just as concisely. Here's my -1. This time I circle it because it doesn't have an equal sign. So I don't want to include the actual -1. There it is. That's our answer. These are both correct, by the way. Let me smile at them. And one more, and then we're done with our lesson. 89.3. Graph on a number line. X is not less than -2. And if x is not less than, that's only one thing we crossed out. It means there's 2 possibilities. There it is. And graphing is no different than anything we've ever done before. Color that in. Boom, chicka boom. That's the right answer. Just looking, John says. Oh, he's just making the point that we color it in when there's an equal to sign and we leave the circle open when there's not, right? We've talked about that. If you have any confusion about the whole do I color it in or leave it open, talk to me on our video chat and I will clarify that for you, but it's super important that you understand. Yay! It's important that you understand everything, isn't it? Because math is the study of specifics and we don't generalize and we don't say it's all more or less the same. Math, you got to know all the specifics. And that's what makes it hard. And that's why we have to stay on top of it every day. Right? Right. Okay, that's the end of the 89. Goodbye.